Okay, so yeah, tonight we're gonna look at the laws of indices, and then we'll look at some transposition of formulae. So let's start with this laws of indices. Right, and before we actually go to the laws, right? The word, the word, hold on. The word indices, right? Is really the plural of the word index, right? Which is another word for exponent or power, right? All these are synonyms. So like if you have 2 to the power 4, right? So this is the power or the exponent or the index. The 2 is called the base. You know that before? Yeah, I think most of you would know that, right? So if you notice the laws, you look here, this here captures the laws here. Once the base is the same, right? Base got to be the same before these laws apply, right? Especially these here. So if you have a to the power m multiplied by a to the power n, it's equal to a to the m plus n. It's like you add, add these two. Right? So if you were to have, all right, example, just an example. X cubed multiplied by x to the second power. Long ago, we used to do this. You take this and you expand it. X multiplied by x multiplied by x. Then this multiply, and this x now, x squared now, x squared times x squared. Sorry, x multiplied by x, and then x by x by x by x by you get x to the fifth power. So we're not doing this anymore. We just add these two, right? Add them up. Right? So it's equal to x to the fifth power. You think you follow that?
Yes, sir.
Yeah.
Yes, sir.
You can have something like this too. Let's go with some x squared. Okay. Let me go with let me go with 2xy squared multiplied by 4xy cubed. Let me go with something like that. You can apply the rule still. 2 multiplied by 4 gives you 8. X to the 1 power is here, right? So x to the 1 power times this x to the 1 power is like x squared. Then you have y squared and y to the 3, so you can have y to the 5th power. Right? So you don't have to, expand out the y squared and the y cube and thing, right? So you can apply the laws even there, right? You think you follow?
Yes, sir.
Big down PH. Well, we need to get a space here. The row space. The second rule now, second rule, notice, it deals with division now. So A to the m power divided by A to the n power, you subtract the indices now. Right? So if you have y to the fifth power divided by y to the third power, is the same as y to the 5 minus 3 power, which is y squared. Or if you have something like this, a to the fourth power divided by a to the second power, that's the same as a to the second power because you subtract the indices, right? Maybe 4 minus 3, so a to the second power. And it doesn't have to have just one base. You can have like, okay, let's say the same thing. You got 8x to the fifth power, y to the fourth power divided by 4x to the, let's say, the fourth power, y to the second power, right? The 8 divided by 4 gives you 2. X to the fifth power divided by x to the fourth power, you subtract the indices, so you get x. Y to the fourth power divided by y to the second power give you y squared, right? If you want to do it in pieces, right, you can write out the 8 divided by 4. Then you do the subtraction of the indices. And so, no problem, you want to do it in more steps. The examples are clear?
Yes, sir.
Not very difficult. But these are very useful, laws in algebra. And then they're telling you the third one now for this one. A number to the negative power is the same as 1 over the number to the, well, you use the positive instead, right? So if you have x to the minus 1, that's the same as 1 over x, right? X to the minus 2, that's the same as 1 over x squared. Easy? Then look at this one. If you have a to the power m, and all of that is raised to the n power, you can now multiply the m by the n. And that is what a is raised by. Right? So I'll give you an example. You have y cubed, you square in that, you will get y to the 6. Right? It's like you multiply these two. Right? You could also have this as you have x squared y cubed cube. Then you will have one. This 2 by 3, so you get x to the 6 multiplied by y to the 9. Following? Go to the other one now. You have a And the power is a fraction, right? Let me raise that. Yeah. So what you do, you raise the a to the m power, and you find the nth root of it, right? So what I mean is you have a to the 2/3. What that really means is that it's a squared, the cube root of a squared, right? Cube root of a squared. And let's do another one here. You have y to the 1/3. What that simply means is the cube root of, well, you don't have to put y to the 1. Y to the 1 is the same y. That's why you have, okay, you have x to the half. What that means is the square root of x. Right? No need to put the power 1 up here. No need to put it there. No need to put it there. But and the last one is not really a rule, right? That's not a new rule. That comes from, it actually comes from this one here. Or this one. See there? What? What's something? A to the 4th power divided by a to the 4th power. You know there's 1 because a to the 4th and a to the 4th is the same thing, right? Something divided by itself is 1. But if you apply this rule, you will get a to the 4 minus 4 equal a to the 0, right? Which is 1. So a to the, well, what's it? It's supposed to be 0, right? A to the 0 is equal to 1. Oh, and a can't be 0, right? Cannot be 0, right? This rule only applies to when a is not 0, the non-zero number. Any number except 0. Any number, non-zero number that is, raised to the 0 power is 1. And you see the reason why. It comes from this second rule. It takes some time to process it.
Excuse me, sir.
Yeah.
Can you please explain back E and F? I'm kind of confused.
Good. E is simply stating that if you were to raise a power, let me use like, okay, x to the 3/5. You raise the number to the numerator power. So you do that, x cubed. And the number at the bottom here, you find that root, the 5th root of it. So whatever is in the numerator, you raise the number to it. So that power. Whatever is in the denominator, you find that root of the number raised to the numerator power. So if you have x to the 3/5, you are raising x to the numerator, which is 3, and you're finding the 5th root of x cubed. I'm going to use some smaller numbers, as I said, a to the, let's say, 2/3. You find a square, that's a to the power on top. And then afterwards, you find a cube root. There's something named cube root, right? As a matter of fact, you don't have any root. And then the last one. If you can't see how it comes from this, forget it. Any non-zero number, any non-zero number, you all know what that means, right? Number can't be zero. It got to be 2 and all kinds of other numbers. -1, 10, 20, can't be zero. Any non-zero number raised to the power 0 is equal to 1. Any number that is not 0, any number other than 0, raised to the 0 power is 1. Let's do a few more examples. Let me cut some stuff from the board. Oh, what did I do? Yeah, look at this one. And that's the other. Right? So you have to do something like this. The 3 by the 2 by the 4, you want 3 multiplied by 2 multiplied by 4. And you have times x. Now you don't have to write it out. You add the powers, right? 5 plus 4 plus the 1 here, right? Plus 1. And then y times y. You don't have to put a multiplication sign, right? Where you are, y to the 1 plus 2, right? There's a power 1 there, even though we don't normally write it. Plus this 2 here, right? So you get 3 by 2 is 6 by 4, 24. X to the 5 and 4 and 1. 5 plus 4 and 1 is 10. X to the 10 power. Y to the 3 power. Tell me if you follow. Multiply all the coefficients in front here. You get 24. You don't have to have this step. You can watch this thing and tell the answer. Add the powers on the ends. 5 and 4, 9 and 1, 10. Right there. There's a y, you get y to the 1 power plus this 2. 3. Follow it?
Yes, sir. Yes, sir.
All right, so okay, right. Big this up. Let me go for another. Look at this one. So you have 8 x to the minus 5 power y divided by 2x cubed times y to the minus 4. This is an alternative way This is an alternative way of writing the same thing, right? Put this divided by 3. So what do? We subtract indices, right? 8 divided by 2, you get your 4. I think you want to write that as up to you. Then x to the minus 5 minus this 3, right? And you're dividing y to the, what's that? 1 minus 4, right? But there's a 1 there. 1 minus 4. Remember? You're subtracting the indices. So your 1 minus, but under there is not 4, it's minus 4. So that becomes, well, 8 over 2 is 4. This here becomes x to the minus 8, right? That now becomes y to the 5th power. And if you were to use this rule here, this will become 4 y to the 5th power over x to the 8th power. Because we have x to the minus 8, you see? If I want to do back that differently, this is 4 multiplied by, well, this piece can be written as 1 over x to the 8th, sorry, x to the 8th multiplied by y to the 5th power, right? Yeah. So what I'm going to do, I'm going to put this 4 at y to the 5th power on top. 4y to the 5th power. At the bottom, put x to the 8th. So sometimes it's a whole, more than one law is being applied at the same time. Let's go now. Look at this one. We're going to make use of this one mostly, right? So 3 square, right? It's do it differently, you know, you can it's like 3 to the 1 power, even though you don't see it, right? So 3 to the 1 power square, right? All right, we got x to the a quarter power, right? I don't need to put this here, but just put multiply. It's plus 3 to the 1 times 2. X to the quarter times 2. Y to the half times 2, right? I'm using this rule all the time. So that's 3 square, which is 9. Half by 2 is 1, right? So you get x. Oh, one of them is a quarter. Sorry, this is a quarter. Quarter. So a quarter by 2 will give us a half. And a half by 2 give us 1. So you have to put 1 here. That's your answer. An alternative way to write this now is this. 9y square root of x. Right? And that's, I'm making use of this piece now. This one here. Write the x to the half power.
Sir, how you get it 3 only 1 by 2?
Everything in this bracket is governed by the square outside. So you have to square the 3 thing. Even the 3 has to be square. That's what you see. 3 times what? 3 to the 1 power by 2, which is 3 square, right? 3 square. 1 by 2 is 2. So 3 square is 9. Good. So besides uh, symbol, oh, yes. Besides symbols, you can have actual numbers too, right? Like sometimes I see what do you tell you, find the value of the value of 25 to the half power. That's simply the square root of 25, which is 5. You know? Let's say you have 32 to the 2/5 power. What that means? It means the 5th root of 32 squared, right? How do you do that? Right? Well, I'm borrowing these from a worksheet, right? So from some notes. So this number here, right? This number here. Let's just say you square it, right? So you get the 5th root. 32 squared is how much? Punch it in your calculator and tell me.
Ten 24, sir.
324?
No, sir.
No, not.
1024.
Oh, 1024. Okay. Yeah. There are calculators that can give you any root, right? 5th root, the 100th root, anything. Just go online, you can find calculators of that sort. But if you can't do that, what you could do with this is see if you can, okay, let's say you break that up, right? We go into the 5th root. 32 is what? 2 multiplied by 2 multiplied by 2 multiplied by 2. How much is being like? 4, 8, 6, 42, right? Uh, um, how much is it? Yeah, okay, so this is 32. Multiply by another 2r. Let me see if I can make sense. This might be too above your head. A. Multiply by 3, right? So you have here, it's like 4 multiplied by 4 multiplied by 4 multiplied by 4 multiplied by 4, right? 4 multiplied by 4 multiplied by 4 multiplied by 4 multiplied by another 4. 5 4, right? 1, 2, 3, 4, 5. So the fifth root of this is 4, right? But that might be something beyond you, right? You can actually take this, put it in a calculator, get the what is it, 10, 24, the fifth root of that, and you will get 4. You will get 4. They have these root calculators online too. You type in, right? Nth root calculator. I think I'm doing another course with some um, business mathematics students, and well, they have these ugly formulas, and they say, "Sir, how do you expect me to find the 10th root of something?" It's simple. You go online, you type in nth root formula, and you get, I think, the name of the site, I found one of them that give you any root in this whole wide world. Calculate for something like that. Let's say you have one like this. 27 to the minus 1/3. Right? What do you do with that? How do you deal with that? Well, you get with different ways, right? Watch this way. Do you see 27? Sorry, what am I doing? Okay. Do you see 27 as 3 to the third power? Do you see 27 as that? Huh? Do you see 27 as 3 cubed?
Yes, sir.
We use this rule then, this rule, right? And you will get 3 to the minus 1, and then we use this rule, and that will be 1/3. Oh, now that you mentioned that, yeah, I was doing that the previous one the hard way, huh? I did it the hard way. Let me go it back. You got this though? Let me go back that one. I was doing things the hard way, man. Why didn't I see that? What was that? 32 to the 2/5. So 32 is really what? 2 to the, is that 2 to the 5th power? 32 is 2 to the 5th power. So when you multiply that out, you get 2 to the 2nd power, which is 4. What was I doing, man? What craziness was I doing? Yeah. Good. Let's take another one. Last one. 8 over 27 to the minus 2/3. Right? So you can see 8 is really 2 cubed. So you gotta know one thing here, right? 27 is 3 cubed. Put that now to the minus 2/3. So that will be equal to 2. So you put 3 multiplied by minus 2/3 over 3 multiplied by minus 2/3, right? This will bring us to, see what the, so you end up with this 3 and that 3 you cancel. You have 2 to the minus minus 3 over 3 to the minus 3. Right? Which is, do you recognize that? Okay, 2 to the minus 2. All right, let me write that back. What's going on here? 2 to the minus 2. 2 to the minus 2 is the same as 1 over 2 squared. And notice 3 to the minus 2, right? Okay, divided by 3 to the minus 2 is 1 over 2 squared, right? So I replace this line with a division sign. So this is 1 over 4 divided by 1 over 9. So you flip this over and you multiply. So it's a quarter multiplied by 9 over 1, which is 9 over 4. Right? And if you can do this up, which is 2 1/4. And it can get very, very complicated, you know. Follow it? Take some time to digest it. Some of these things you might have to get familiar with, like 8. That 8 is the same as 2 to the 3rd power. That 27 is the same as 3 to the 3rd power. Sometimes you can't know that, right? So what we can also do with indices is we can have equations where the unknown is in the index, right? So we might have, okay, everybody's familiar with an equation where, all right, you have to solve 2x plus 1 equal 5. You bring this one over here, you get 2x equal 5 minus 1, 2x equal 4, and you divide throughout by 2, x then equal 4 over 2, x equal 2, you know that. But you can have a situation where you have the unknown in the power. Like you have, okay, let's say you have to solve something like this. Solve 2 to the x equal to 8. Right? The unknown now is in the index or the power. How do you solve for x there? Right? And you might know that, okay, 8 is the same as 2 cubed. So if the bases are the same, then the powers got to be equal. Right? X equal 3. You see that one? Let's take another one. 2x minus 1 equal, let's say, 32. We just learned that 32 is the same as 2 to the 5th power. Right? So let's say, okay, oh, I forgot to put in. You're asked to solve for x, right? You have 2 to the x minus 1 is equals to 32. X minus 1. Like a single mosquito bit me. And sometimes what's happening is start to give you an itching that persists well after the mosquito gone. Yeah. So you remember that 32 is the same as 2 to the 5th power. So if the two bases are the same, then the powers are equal as well, right? So x minus 1 equal 5, which implies that x equal 5 plus 1, right? You take the minus 1 over it. X equal 6. Think you're following that? So you can have equations that involve the unknown being a power. Huh. So far we can go. Let's try another one. Let's say you have solve for x. So this is the last one. You have some of this. 6 to the 3x equal to 36. Let's just say that. Now, you know that 36 is the same as 6 squared. So 3x then is equals to 2. X then is equals to 2 thirds. All right, let's do a last one. Let's say you have 3 to the x minus 1 over 9 is equals to, let's say, 27. 27. Right. Equal 27, right? So what you can do here? All right, so you can write 3 to the x minus 1. Make some master. Something by the right? We make some shoot. Shoot equivalent. Over 3 squared equal 3 cubed. Right? So I can probably cross multiply there, right? So you have 3x to the minus 1 equal 3 cubed multiplied by 3 squared. What happens? So you can add these indices. So 3 to the x minus 1 equal 3 to the 5th power. And since the bases are the same, then x minus 1, the power is got to be the same, which implies that x equal 6, right? You bring in minus 1 over here, becomes 6, right? 5 becomes 6. These are simple equations that involve the unknown being in the power, and your knowledge of a little bit of indices can help you through them. Right? Good. What we could do, we could take a pause here. We're going to do a little bit of transposing of formulas. Right? So take a little break, because we're going to switch gears a little, you know. You want a little break, come back at maybe 7 o'clock. Right? Take a few minutes. Come back at 7 and we proceed, right? Take a 10 minutes. Well, not 10 minutes, but yeah. Take a 10 minutes. Rainfall. Wow. Huh? Rain falling. I was taking a little break. Oh my. And I got my recording on, and so the students hearing me. Are we back?
Yes, sir.
Yes, sir.
All right. So we want to turn our attention now to so let me see the textbooks refer to as changing the subject of a formula. Right? Or sometimes you see this phrase, transposition, big word. Transposition of formula, right? Yeah, let me see this instead of that. And mathematics is full of formulas, you know, so many formulas are there in maths. Some very famous one will be where you might have a little, let's say you have a little rectangle, that's the length, that's the width. There's a formula like this. Perimeter is equals to 2 times the length plus the width. You know, sometimes you don't, you say, well, look, I want to rearrange this formula to make L the subject, meaning you want to have L equal to something. Or you want to rearrange the formula so you have W equal to something. And that's what this part is about, you know. How do you rearrange a formula? Right? How do you rearrange a formula to make different unknowns in it, right? Or different variables, you call it. How do you make it the subject? And well, as we mentioned, formulas can get from very, very simple ones like this one to very, very complex ones, you know. So let's maybe start with the same one. All right, let's say you have one, right? P is equals to 2 times L plus W. Right? Some serious masses coming in. Yeah. So you want, let's say you want to make L the subject. Right? First, you got to get rid of this 2. The 2 multiplies here, right? So what we could do is divide throughout by 2. So you have P over 2 equal to L plus W. All right, so we got rid of 2. Now we want to get rid of W. Now we notice that W is connected with a plus sign here. It's added, so you can subtract it from both sides, and you get P over 2 minus W equal L. See? There you're able to make L, right? If you want to write it back, it's up to you. Equal P over 2 minus W. And they get, of course, they get complicated after this, right? Like if, let's take another one. You all know the area formula for like a rectangle. Length by width. So area equal length by width. So let's say you want to make L the subject. So L is multiplied by W. So you take the W across and divide. So you have A over W equals L. Right? If you want to write it by, you can write it by this. It depends on how these unknowns are connected. In the previous one, notice, all right, let's go back to this previous one. You had 2 multiplied by this whole bracket. So to get rid of the 2, you have to divide because it was multiplied here. After you have done that, these 2 are connected by addition. So you have to subtract to get the W out of here. Right? In a similar way, if you look back here, L and W is connected by a multiplication sign. So to get rid of this W, you have to divide, right? So you divide throughout by W. The shortcut is you just put A over W. You get L. Right? You can have let's say you have a formula involves subtraction. Okay, there's a formula in physics, V equal U. Oh, no, let me go with this. A is equals to V minus U over T. Let's say this. Right? Here you have division and subtraction. So there's different things people say, right? You can multiply both sides by T. Right? Look at what happens. A by T is equals to V minus U over T times T. So these two will cancel. You get AT equal V minus U, right? Oh, sorry, we're make V the subject, right? So now this is connected by means of a minus sign here. You want to take this over there, you end up with AT plus U equal to V, right? Usually they write it like this, V equal U plus AT. An alternative way people do it is this. They take this, right? A equal V minus U over T. And they do something called cross multiplication. Cross multiply like that. So you end up with AT equal V minus U. And then you take over U and you get U plus AT equal V. Right? This is the same thing as that. Follow so far? Let's try another one. So make, all right, make V the subject. All right, so you have, there's a formula in physics, current is equal to voltage over the resistance. And the simple cross multiplication will help you there, right? I over 1 equals V over R, and you cross multiply. Array, see? And you get V equal, I would like to say IR equals V, right? Just not to confuse you. R by I will do this, 1 by V will do that. So V equal IR. Follow that one? Now suppose they don't want that, right? They want, let me remove this and go back to use the same one. And they say, look, let's make R the subject. Make R the subject. Make R. So you follow the same procedure. Put this over 1, multiply like that. You get IR equal V. Now you want to get rid of this I. So you divide through by I. You get R equal V over I. See? So not every time at one go you get your answer. Let's try one that involves a square sign. All of you know this formula. A is equals to pi R squared. Make R the subject. Right? You want R. A is the subject right now. You want R. So there are more than one ways, but let's say you first get rid of this pi by dividing by pi. So A over pi equal R squared. To get rid of a square sign, you have to square root both sides. So when you square root both sides, you get square root of A over pi equal to the square root of R squared, which is, this here is R, right? A over pi equal to R. You can write it back if you want to put the R in front, right? That's all. And they go on and on like that, you know. They have all kinds of complex ones. We can do a last one last one. There's a famous formula in physics. T is equals to 2 pi square root of L over G. All right, this is the period of a pendulum. And let's say they want to make G the subject. Right? Because very often G is what they call acceleration due to gravity, right? And very often they want to rearrange this formula to make G the subject. So what can we do? Right? Well, let's start by maybe, okay, bringing the 2 pi over here. So you have T over 2 pi equals to the square root of L over G. Just now, to get rid of a square, we square root it. Now, to get rid of a square root, what do you think we should do? Any suggestion from you? To get rid of a square, we square root. the thing, the previous one. Now we have a square root. What do you think we should do? To get rid of that square root sign. Huh?
It's squared, sir.
Square it, yes. You square both sides. Square both sides, right? So you get t square. Well, if you want to put t over 2 pi and square everything, no problem. Equals to L over G, and you square that. And you end up with, let me make it a little smaller. Take it up a little. So you have t squared over, that's going to be 4 pi square. 2 square is 4. It's equals to L over G, right? So what we could do now is cross multiply like that and like that. And you will end up with GT squared equal to 4 pi square L. And now you got to get rid of this t squared. So you divide throughout by it. So you get G equal to 4 pi L squared all over t squared. Right? Some people like to write this here as equal 4 pi L squared over G squared. Like, sorry, over pi squared. Pi squared. Some people like to write it like that. This is T, right? This is T. Right? Sorry, not T, pi. What am I doing? Over, not pi. What's happening with me tonight? I'm tired. Over T squared. Wait, let me go back. Let me go back from here. What person is answer? Yeah. So 4 pi square L. Why did I have L square? All of this is wrong. So you divide through by t squared. So G will be equal to 4 pi square L over t squared. Right? Yeah. Something I read got wrong this one. I know you have G as the same. Let me try a last one. I did say I did say that was the last one, right? Yeah, well, we'll do one more. There's a famous formula in mathematics to the volume of a sphere. V equal, I think they have, well, they write it like this, 4 over 3 pi r cubed, right? Pi r cubed. Sometimes you can write this as this. V equal 4 pi r cubed over 3. Right? And let's say you want to make R the subject. Well, for whatever reason, you want to find R. Good. So one of the first things we can do, we can cross multiply like that. Right? You can cross multiply like that. So you get 3V equal to 4 pi r cubed. Then we can get rid of this 4 pi here by dividing. So we have 3V over 4 pi equal to r cubed. And to get rid of this cube sign, we cube root both sides. So you end up with, let's see if I can move this up a little. You have 3V over 4 pi cube root with a little 3 in this whole thing equal to r. Get it? Some people can write this. They take the same thing and write it back as R equal the cube root of, they put this 3/4. Oh, no, oh, let me not write it like that. No, let me not write it. Let me write it as just 3V. 3V over 4 pi. Leave it at that. I was going to separate the 3/4 from the V over pi. Yeah. I will send you some notes with some more examples in it, with both indices and formulae, right? Before Wednesday, you'll get it, probably latest Wednesday morning, because tomorrow is a taxing day for me. I will not get a chance to, but I'll send it before Wednesday. And then, of course, when you do the tutorial, you'll get a chance to try some of your own, so that you get some more practice, you know? Mhm. Good. So I think that's a nice introduction. You know, you get some of them that are very, very complicated. I'm not going to take you into those hard ones. You got to get a lot more math training before you can handle the very difficult ones. I think this one is at the right level for you. You can't go beyond this. Good. So we'll stop here, right? We'll stop there.